Greetings, there is something invisibly massive that is disturbing the orbits of other objects in our solar system. We thought it was Planet 9, some call it Planet X, however, the latest research is pointing towards something else. For a long time, there has been talk of an immense planet at the edge of the solar system, beyond Neptune and Pluto, that is disrupting the orbits of trans-Neptunian objects. Astronomers haven't seen it, but they observe its gravitational effects on other bodies, and everything indicates the presence of a high-mass object causing these disruptions. Nevertheless, a new study suggests that this hypothetical planet, known as Planet 9, doesn't exist, but instead, it's a black hole. This would imply that there's a black hole located at the outskirts of the solar system. There is cause for concern. Let's analyze the available data. I previously mentioned that there are many black holes scattered everywhere. These are remnants of the universe's formation when it was still hot due to quantum fluctuations and incredible tensions in spacetime during its early stages. Matter accumulated more in certain regions than in others, and in denser regions, many black holes formed. These are also called primordial black holes. Some of these black holes are smaller than an atom, and in the case at hand, it seems to be disturbing the orbits of solar system bodies. Not only that, but we've noticed that in certain directions, the light entering our solar system gets distorted, and the cause isn't found. This could be due to undiscovered dwarf planets, a wandering planet not bound by our star's gravity, or perhaps the most likely hypothesis for light distortion, a singular culprit, a mini black hole. Curves in light are undeniable signatures of black holes. Although in this case, it would be a different kind of black hole, not large enough to engulf the entire solar system, nor as small as an atom. It does, however, seem to be a miniature black hole, a primordial black hole born from the remnants of the Big Bang. It wasn't formed by a supernova explosion, but by the accumulation of primordial matter. The scientists proposing this possibility are physicists Jakob Schultzes and James Unwin from the University of Durham in the United Kingdom and Illinois in Chicago. And this hypothesis aligns perfectly with the mathematical models typically used by astrophysicists for such objects. Usually, when we can't see an object, calculations provide many clues about its mass and behavior. It's worth noting that these hypotheses are often correct, leading us to discover pulsars, black holes, the nature of light, gravitational waves, and much more. The possibility of having a mini black hole in our solar system is considered more likely than a giant planet. We believe that such a planet should have been detected by now, as the discovery of exoplanets generally relies on gravitational perturbations causing a star's wobble or a decrease in brightness as a planet passes in front of a star. However, this isn't happening with Planet 9. We can't even uncover the elusive Planet 9 in infrared studies. With that not being the case, we're left to ponder what hidden entity in the darkness, an invisible object of significant mass, could be disrupting other bodies. The only remaining hypothesis is the black hole. Black holes are invisible objects, only becoming visible when they're absorbing matter around them, which then lights up due to high temperatures. According to calculations, the object causing orbit disruptions has a mass between 10 and 15 times that of Earth. This implies a black hole of this mass would have a size roughly that of a ping-pong ball, with an event horizon approximately the size of an orange. Nonetheless, gravity does influence dwarf planets and asteroids similar to a planet. At the moment, we can't distinguish whether it's a planet or a tiny black hole orbiting the Sun. The supposed black hole would be 1,000 times farther from the Sun than Earth, about 20 times the distance of Neptune. This means it receives very little sunlight. It's possible that the black hole would be trapped by the Sun's mass, interacting within the solar system and becoming part of it. Such black holes have so little mass that they could outlast the age of the universe. Thus, no mini black hole has disintegrated within the universe's age, and they might be plentiful even if, for now, they're mathematical objects. Researchers believe they exist. We know that there are 3 types of black holes based on their mass. We have observed 2 of them. The first ones are supermassive black holes, forming at the centers of active galaxies like ours, and they can have thousands or even millions of solar masses. Then there are stellar mass black holes, which form from the explosion of a massive star and have a mass ranging from 5 to 30 solar masses. There exists a third, still speculative type, known as primordial black holes, which could have formed in the first moments of the universe and might have the mass of an asteroid or several dozen Earth masses. These could be detected through gravitational microlensing. So, if a black hole passes between us and a distant star, the star's light would be bent by the gravity of the mini black hole, causing changes in the star's light. This method could also be applied to black holes within the Milky Way. It has also been concluded that there might not be just one, but several primordial black holes. Several mini black holes could add up to 10 Earth masses or perhaps represent a new type of unexpected exotic object. Whether a black hole or not, what we do know is that something invisible is disturbing the orbits of asteroids, comets, and certain dwarf planets in the Kuiper Belt. Additionally, these objects have a distinctive tilt. The debate between Planet 9 and a black hole remains open. However, the fact that an object of significant mass is causing these disturbances is irrefutable based on the gravitational disruptions of trans-Neptunian objects. We know its mass, but not its composition. Now the question is how to confirm whether this hypothesis is correct and how to detect an invisible object. I suppose we must rely on imagination. A black hole, no matter how invisible, always leaves some debris around it, and researchers believe there should be a halo of dark matter extending possibly up to 1 billion kilometers. The problem here is that we also don't know how to detect dark matter directly, although we can observe the interactions it has with other particles, such as gamma-ray bursts and antimatter. And for this, we have the perfect candidate, the Fermi Gamma-Ray Space Telescope. This telescope has been studying the sky for 11 years. There's no doubt that studying the outer reaches of the solar system with this telescope can help us uncover the truth. By looking for these kinds of gamma-ray bursts and high-energy cosmic rays moving similarly to how Planet 9 would. Given its specific orbit, unlike a static object, we'll likely have more data in the coming years as we scrutinize a significant portion of the sky. If it were a black hole, it would be a thrilling discovery, possibly one of the most significant in the history of science. This means we would have a black hole in our own solar system that we were unaware of until now. Like any massive object, the black hole should have an extremely eccentric elliptical orbit around our Sun and could complete this orbit in over 15,000 years. I don't believe there's any danger to Earth, although it's a planet-mass object and could absorb surrounding matter. It's neither large nor powerful enough, nor close enough, to pose a threat to the solar system. It might have been here for thousands of years already, though its impact would be significant in the outer solar system. And even if it were to approach Earth, the most that could happen is that it would perturb Earth's orbit or, at worst, if it came exceptionally close, we might end up in a highly elliptical orbit around it. We acknowledge that this hypothesis is speculative, but it's not illogical. Sometimes, even the most seemingly wild imagination is necessary to uncover what's hidden on the horizon. As Einstein said, imagination is more important than knowledge. Science always tends to keep an open mind as long as calculations align with hypotheses. The idea of a mini black hole, a relic of the Big Bang, is perfectly plausible. Moreover, through this study, we could better analyze dark matter within our own solar system, enhancing our understanding of the cosmos. And who knows, we might discover the unexpected. If you enjoyed this video, please like and subscribe. Share it on social media and leave your comments below.